everyone, and welcome to today's workshop on the Mediterranean Sea for the Copernicus Marine Service. My name is Ivàn Parras-Berrocal, and I'm a Training and Capacity Development Officer at MyOcean International, and I will be your host for today. Over the course of this training, we will explore key aspects of the Copernicus Marine Platform and its data. And on today's session, we will tell you what the Copernicus Marine Service is about and what sort of data and products you can find, and show you a few applications you can do with it. Before we start, we are going to go through some house rules and guidelines to make sure you enjoyed this webinar. First, we ask you not to use the chat that you see on your right-hand side for your questions. You can use it for small talk or to say hello to each other, but if you have a more technical question or content-related question, we invite you to use the Q&A section. So you will find the Q&A button on the top of your screen. Simply click it to open the dedicated space where you can ask our speakers your question. So I just want to show you the slides with the Q&A. Okay, yeah, so you will see the Q&A button there and then the dedicated section. And while you're there, you will also see a quick survey about this training workshop. So feel free to fill it out anytime during the session. Concerning the agenda of today, we will have many interesting presentations. So we will start with an introduction to the Copernicus Marine Service. And then we will have a presentation of the MyOcean Viewer Pro by Anaïs Perrin from the Mercator Ocean User Support. And then we will have 3 presentations about specific applications of these Copernicus products. So we will start with Ivàn Parras-Berrocal from the French National Center for Scientific Research. And then we will have John Karagiorgos from the University of Athens, who's also a member of the Champion User Advisory Group of Copernicus Marine. And finally, we will have Paola Tepsich from the CMA Research Foundation, also a member of the QUAG for Copernicus Marine. And now we will start with the small introduction of the Copernicus Marine Service. So Copernicus is the Earth observation component of the European Union Space Program dedicated to monitoring our planet and its environment. So the service provides free and openly accessible information services based on satellite observations and in-situ data, helping service providers, public authorities, and organizations to improve quality of life in Europe and beyond. So Copernicus operates through space-based and in-situ observation components and offers dedicated information services through self-standing portals tailored to various user communities. So if you want to access Copernicus Marine data, it's quite easy. So it's free to access the website and download any product. So you will find an extensive catalog of products. All of them are scientifically qualified and user-driven, so they are constantly upgraded and improved. And yeah, as I said, it's open and it's free. You just need to register to the website. Concerning the type of data you can find, so the service provides data on the blue, the green, and the white oceans. So blue is all about the physical component of the ocean, so everything that has to do with the currents, the waves, the wind. Then we have the green ocean, which is the biogeochemical component of the ocean, so the phytoplankton, the nutrients, chemical composition. And finally, the white ocean, so everything that has to do with the ice, so the sea ice coverage, velocity, ice concentration. And that's it, basically. You can go on the website if you want more detail, but that's basically what the service covers. You will also find several types of temporal and geographical coverage. So it includes, as we said, in-situ data, satellite observations, and model data. You can also find data that are measured right now, which we call real-time data, but also from the past all the way back to 30 years. that we call reanalysis on multi-year, and we also provide forecasts 10 days into the futures. And in terms of geographical coverage, we do cover 5 areas or 6 regions, the global region and smaller area all around the globe, all around Europe, sorry. And you will see that we have a dedicated coverage on the Mediterranean Sea. Also on the website, you will find a visualization tool, which is called MyOcean Viewer. So you have 3 versions of this visualization tool. You have the Learn, the Lite, and the Pro, and we will have a demonstration of MyOcean Pro right after my presentation. And we will show you how you can select a product and visualize it in a fun way on the viewer. So you will see it's really interesting, and it gives another perspective to the data. We also provide specific products like ocean monitoring indicators or data related to the climate. So in this case, the monitoring indicators are key variables that help us understand the state of the ocean. So they are also accessible and free of charge, and they cover the past 30 years. Also, besides data, we also provide information, and one of the ways we do that is by publishing a yearly report on the state of the ocean. And we also provide the Ocean State Report Summary, where we try to target non-scientific communities like policymakers or just the general public. Also, so to make sure that the information gets to everyone, we do that by creating 2 pages on the website called the Ocean Explainers and the Ocean Climate Portal, where we explain some oceanographic concepts or current threats that the ocean is facing. And yeah, we try to explain it to everyone to make it accessible to the most people. So yeah, as you can see, we try to reach a bit of everyone, and the data we provide, so it responds to different needs and what we call blue markets. So it goes from science and innovation to policies, but also to coastal services or economy sectors. And yeah, so for example, also today you will hear about 3 practical applications, so use cases. So it's an example of the use of the data Copernicus Marine Service provide, but on the website you will find many other examples, and we invite you to visit the website and learn from these examples. And if you are a use case yourself, we also invite you to submit your project as a use case. We are always interested to learn more about how the data has been used. So we will put on the chat an email address you can reach out to if you want to submit your use case using Copernicus Marine data. Beside that, so we also try to make sure that the data is not only available and not understandable. We also want to help people use it. So we organize workshops and webinars like this one, but we also organize hackathons or forums or other events to try to engage with the user. So yeah, you can find this type of events on the Copernicus Marine website also. So if you want to have a look, don't hesitate. And finally, I just want to take a few minutes to talk to you about a call for international mobilization to enhance ocean prediction capabilities in response to growing societal and environmental challenge. So it's a document that was launched during the UNOC that took place in Nice in France in June. So the document outlines a series of coordinated actions. The ocean prediction stakeholders commit to strengthen international cooperation and mobilization through several projects. So some of the projects are like the Ocean Prediction Decade Collaborative Center, the Global Ocean Observing System. So several projects are part of this call to action. So the idea is to read the call to action, and if you agree with what it said, you can access the signature and just sign the document. So it's just to enhance the responsibilities on the ocean. So yeah, you can access the signature with the QR code on the slide, and you can also read the document with more detail using the link, and we will also put the link in the chat for you to have a look. And yeah, that's it for me for today. So if you have any questions, don't hesitate to ask them in the Q&A section. And now we will go to the MyOcean Viewer Pro demonstration with Anaïs. Welcome, Anaïs.
Hi, everyone. I will share my screen like this. Hello, everyone. My name is Anaïs. I'm a member of the Copernicus Marine User Support Team. And this presentation, I will introduce you the different feature of our data visualization tool, the MyOcean Viewer Pro. So to access the MyOcean Viewer from the homepage, simply scroll down and click on Try Now in the Dive into our Digital Ocean box. So you will then see our three different ocean viewer, the MyOcean Learn, the MyOcean Lite, and the MyOcean Pro, which is the most advanced and the one we will use here. So when you first open the MyOcean Pro, you will see default layers display on the map, such as the seawater velocity, the potential temperature, and the chlorophyll A concentration. The small blue eyes next to the layers show that the layers is visible, so you can hide it or display another like this, for example, or you can also change your priority order by dragging them up or down. So any layers you don't need can be removed by clicking on the cross, for example. On the interface, you can also change your projection by clicking on this arrow for the North Pole projection or the South Pole projection. You can also click and drag the map and zoom in and out using your mouse wheel. So in March of this year, a strong storm impacted the Gulf of Lion of the Mediterranean. And with the MyOcean Pro, we will look at two key variables during this event, the wind speed, which is the main driver of the storm, and the significant wave height, which is the ocean direct response. So this will let us see how wind forcing and wave development are closely connecting during extreme condition. So to find the projects we need, I click on Add Layer here, and this takes me directly to the Copernicus Marine Data Store, where 303 projects are available. These projects are classified in several ways, such as the most popular, the recently opened in MyOcean, your favorite, and so on. Under each subnail, you will find the product long name and short name, the acquisition mode, models or satellites, for example, the area, may also the temporal coverage, the spatial temporal coverage, and the number of the depth level. It's 3-dimension for models and usually 2-dimension for satellites. You also have the temporal coverage and the variables it contains. On the left, you will see the filters that lets you refine your search by entering keywords, specifying the time period, selecting the 3-dimensional data here, choose the type of the variables, the geographic area, and many other parameters. In our case, we are looking for the wave height in the Mediterranean. So I will select the wave, and I will select also the Mediterranean Sea in the geographic area. And I will also select in the south section the numerical models. So the filters return several products that match our needs. I choose the first one because it's an analysis and forecast product that includes the most recent data. Clicking on the products open the project description page, where you will find an overview of this product, example of products use cases, and the classification section, which details the product's parameters. On the left-hand side, you have several tabs. The notification tabs, where you can track incidents, improvements, or maintenance, current or past, in the product. The data access tab, which lists all the datasets in the product and the different download method. Each dataset, you have the time period for which data is available, and links to available service, subset, files, and maps. Small information buttons will take you directly to related Help Center articles. So here, these articles explaining these download modes. You also have the contact tab to reach user support. The documentation section, which links to useful documents such as the user manual and the quality information document, as well as instruction on how to cite the product in your work. The user manual contains technical details, while the quality information documents give scientific backgrounds and information on acquisition modes. The DOI links, which redirects you to the catalog's products page. At the top right, the share icons allows you to copy the URL and share the product page. So to visualize a variable, click on Add to Map here and select the variables of interest. The filters I used earlier already point the data set I need, but I can also access all the other data set on the product by clicking on Add Layer here. I select the hourly dataset sea surface wave significant height, and I click on Add to Map. Sorry. All right. So next, I want to add the wind speed. So I will click on Add Layer again and clear to reset the filters. I will select the wind variable with hourly data. And this time I will choose the global ocean, since there is no Mediterranean specific product for this variable. I will select this for our case, and then I add it to the map and select the variable wind, which is calculated from the east and the north component. Once added, I press the small orange fix button. This automatically sets the visualization to display the latest data available. All right, I will zooming into the area of interest. So now we have our layers, and we'll see icon on each of them. The download icon to download the data, the information icon, which takes you back to the description page, the layers icon to switch to another variable in the same product, the gear icon to customize the layer, and the log icon to apply a logarithmic scale. The temperature layer here doesn't have the log icon, since the logarithmic scale cannot be applied to it. So by clicking on the gear icon here, I can adjust the opacity of the layer. I can also adjust the style, solid or hatching, for example. So hatching lets you highlight area according to a value. And for example, here, I will show only a wave height greater than or equal to 3 meters, for example. I can also change the color map. invert the color scale. For example, I can also use a discrete color step where I can add, redefine or remove thresholds. I can also set the minimum and the maximum values of the gradient. And for example, only wave between 2 and 5 meters. And I can also choose whether to hide values outside this range, for example. I only see waves between 2 and 5 meters. I can also click on the auto button here to automatically adjust the minimum and the maximum values to the map view. For vectors data, such as wind, here I can adjust the changer styles to solid plus particles, solid plus vectors, or solid plus vector and hatching. So the styles can be combined. So here I will keep only the particles for greater visibility. I can also change the color and the gradient value if I want. At the bottom of the screen, the time bar shows the variable time period of data, and the whitest line indicates the period of time for which the data is available for all open layers in the visualization. I can zoom in with the mouse wheel or use the up and the right and left arrow on the keyboard to step through time here hour by hour because we have open hourly dataset. I can reset with the button, and let's set the date of March 21st, 2025, because it's the day of the storm in the Gulf of Lion. So I will zoom in with the mouse wheel to the 21st March, and I will select the hour at noon, for example. Oh, sorry, noon is here. So I will okay. Oh, that's it. So on the right here, under the object and settings, you will see the depth scale. This scale is visible because I've kept the layers of seawater temperature. So it's defined by depth. So by default, I will just show this layer. By default, the data shown is the surface data, but I can also click directly on the scale or zoom in and zoom out with the mouse wheel, or I can also use the up and down arrow on the keyboard arrows to navigate step by step in 10 meters increment. All right, I will hide it. Just above, you can create object like point, for example, or lines for transect. And I can also create an area if I want, like this. Each object shown graph, and it indicates its coordinate, the transect length, and the area size. The values of the open variables and its minimum and maximum values. Each object generates a graph, a time series or depth profile. It's the data is 3-dimensional. And the graph menu, in the graph menu, I can adjust the axis, and I can set the start date and the end date. I can also download the data of the graph in a netcdf, CSV, or SVG format. I can remove the graph or add a new one if I want. I can also zoom in directly on the graph using the mouse wheel. So I'm going to remove some items for greater visibility, like this. We'll see that on March 21st, waves exceed the 3 meters, and wind here reach 40 kilometers per hour. And the histogram show the frequencies of wave height with strong values during the storm. Another feature lets you import geometries here. I click on the import button and you have here access to predefined geometries. The predefined geometries here with the marine equation and other. The recent tab is a shortcut to recently open geometries. You can also represent the geometries in WKT or import a GeoJSON or a shapefile. So I will select a marine equation here and I will type Western into the search bar and import the Western Mediterranean equation directly into my visualization. So another feature is the possibility to combine objects, which is very useful for comparing region in the single view. So the data will take some time to display due to the geographical area covered in the live stream. In the settings here, you can also log in, log out, change base map colors, change show toponings, or change the projection, define units for objects, and much more. So now to download the data, click on the download icon here on the variable of interest. So you need to be logging. If you're not, the viewer will prompt you to do so. And as a reminder, the registration is free. And the geographic area here, you can either type coordinates manually or use the define on map option here, which allows you to directly create the desired area on the map, or you can also select an existing object. Reminder that when you download, it covers the bounding rectangle of the object and not just only the exact shape of your object. The date range must be with the time period available right here. You can also use the as in map option to match the currently displayed dates. So now I will change. Oh, sorry. I will change the date, for example. For a 3D data set like the sea potential temperature, you also have the depth range, and you can enter the range of interest and use the as in map option too. You also have the also download a section allows you to download several variables contained in the dataset at the same time. When you're ready to download, you can click on the download button for direct download from the interface up to 800 megabytes. The automate button, which generates a download template for the Copernicus Marine Toolbox. This method allows you to exceed the 800 megabytes limit and pause by the online downloads. So two templates are proposed, one executable from the command line interface and another from Python interface. You also have the browse file button here. So it's for retrieve original files as distributed by producers, usually organized by a year and then month, and it's covering the full area. So these files are not subset. If you need assistance, you can click on the bubble at the top, talk to an expert, and windows will appear here. And you can ask a question directly to Blue or AI assistant, or contact a human agent. If you face an issue with the downloading, please copy the template so when you contact the support, so the team can investigate. You can also access Help Center articles directly from the Help tab without leaving the page. And for example, typing MyOcean bring you here to our introductory article with a very useful Q&A section here. So we answer the most frequently question asked. You also have the share icon here. So this icon, the share option, allows you to share the link of your visualization. You can also create an image of your visualization or a video, or generate an embedded link to add it on your own platform. Finally, the information icon here. Sorry, it's yes. The information icon shows statistic on the volumes of the data download each week in MyOcean, and it also lists the variables keyboard shortcuts for smoother exploration. Several articles are available in our Help Center about the MyOcean Viewer and more. The support team is always there to help you if you encounter any difficulties. Thank you all for your attention.
Thanks a lot, Anaïs, for the presentation. So yeah, it was really interesting, and we have a few questions for you. So we'll go to that part now. The first one being, can we save our progress or history to continue our work later, or to make some corrections or edits?
Yeah, your visualization, you can save your visualization by copying the link of your visualization, and the objects, layer, and settings will save. So you can continue your work later.
Okay, great. So not just to share with people. Then, okay, this question, what is the programming language used to analyze the ocean data using MyOcean Viewer?
So I don't have the response of this question. We need to contact the developers. So you can contact the support, and an agent will take the time to look into it.
Okay, thanks. This one, so I think you kind of answered during the presentation. How can we be sure about Copernicus data accuracy? I think there is a document on the product with how it's being validated, if I'm not mistaken.
Yes, we have a document in our Help Center of a website, but I have to confirm this. But sure, we have some document that explain this accuracy.
Okay,
But
okay. Yeah, to be checked in detail then.
yeah.
So in MyOcean Pro, do you also provide pre-calculated indices such as mean 8 wave intensity or number of days above T threshold, or can we implement our own equations? I think you can just see the products available. You can change what you see with the viewer, if I'm not mistaken.
Yeah.
Oh yeah,
We cannot implement your own equation for sure, but provide pre-calculate indices. I'm not sure of this.
The first one is marine heat wave and not mean heat wave. I guess, yeah, we can see marine heat wave by looking at the temperatures, but yeah.
So please contact the support again, and we will investigate.
Okay. I think that's the last question on the viewer. Okay, now I see one in the chat. So let me just, yeah. Okay, yeah, it was a bit slow to appear on the screen, sorry. Is there a way to create a polygon on Ocean View by entering specific coordinates? Because drawing by clicking on mouse may not pinpoint specific coordinates. So you can enter the coordinates, but just 4 points, if I'm not mistaken.
Yeah, you can import your own geometries in WKT or GeoJSON or shapefile to import directly the geometry into the viewer. But as I said, the download is when you download the data from the object, it's download all the data bounding the rectangle of this object. So for the moment, we don't have into the viewer the capacity to download the exact shape, but you can import your geometries and download the data in the graph generated by your object if you want, but that's it.
Okay, thanks. Still useful. So I just also have this question. Yeah, it's slow still. Okay, so as you mentioned, it is possible to submit a proposal. Could you explain this in more detail and what exactly does submitting a proposal mean? What are the benefits of doing so, and how can we go about submitting one? So I asked if it was about the use case that I mentioned during my presentation. If that's it, you just have to submit your project as mentioned, and you will be published on the Copernicus Marine website. Yeah, it gives visibility to your work if you use the Copernicus Marine data. And yeah, you will find the email to address this on the chat. And yeah, you just submit the paper and a few extra information, and you will be guided through the process of having it published on the website. Okay. And yeah, so I think that was really it now for the question on the viewer. Thanks again, Anaïs, for the presentation.
You're welcome.
And yeah, some kudos for you on the chat.
Bye.
Bye. Okay, now we will go to the use cases presentations, and we will start with Ivàn. Welcome, Ivàn.
Good morning. Can you hear me properly?
Yeah, we can hear you.
Okay, so good morning, everyone. My name is Ivàn Parras-Berrocal. I'm a postdoc researcher at CNRS in Toulouse. And my talk for today is entitled Understanding Mediterranean Surface Circulation Through Cements Product and Multimodal Assessment. Okay. Well, sorry. Okay. So let me start with a brief introduction of the Mediterranean surface circulation. These circulations consist in the entry of Atlantic water through the Strait of Gibraltar, flowing eastward of the African continent to form this Algerian current. And once it reaches the Sardinian Channel, it splits in two main veins, one recirculating counterclockwise through the Western Mediterranean, and the other one which continues flowing through the Sicily Channel to the Eastern Mediterranean. This has a well-established pattern, and this circulation is well characterized by the mesoscale activities, typically with cyclonic circulation in the northern coast and with anticyclonic circulation towards the southern coast. Well, but how is going to impact the expected global warming on this surface circulation? Because this impact may introduce effects on regional sea level, marine species connectivity, also can lead to enhanced local surface warming. So despite its importance modulating the climate, the Mediterranean surface circulation has not been deeply assessed for the future. That's why last year we published this paper entitled Response of the Mediterranean Surface Circulation at Various Global Warming Levels, a multimodal approach. You can find the link to the publication if you scan the QR. And in this analysis, our main objective was to study in a robust way the response of the Mediterranean surface circulation at different levels of global warming. To achieve this goal, we collect all available information from fully coupled and regional climate system models from the MedCordex framework. And in total, we collect 28 multi-decadal simulations from 9 different regional climate system models. And among the simulations, 11 were historical simulation and 17 scenario projections, including low, moderate, and high emission scenarios from CEMIC 5 and CEMIC 6 exercise. So this was the largest ensemble ever used to analyze the Mediterranean climate. But before analyzing the future signal of at different levels of global warming, we start with a multimodal assessment. And here is where we are going to focus our talk for today, because it's where we use the Siemens product for this model assessment. Well, as you probably know, at the ocean atmosphere interface, where the momentum balance is driven by Coriolis acceleration, pressure forward, and vertical turbulent fluxes, the total surface current can be calculated as the sum of the geostrophic and ageostrophic terms. So for that, to compute the geostrophic term, we use monthly output from the models from dynamic sea level, and we compare the model outputs with two products of marine Copernicus. One is based on altimetry satellite observations, and the second one is based on Mediterranean reanalysis. For our assessment period, we took the 1993 to 2005 period because it was the longest overlapping period between the observations and all the historical simulation from all the models. And then to compute to validate the ageostrophic terms, we use model outputs from wind stress. And in this case, we also use Copernicus data. But in this case, we download from the data from the climate change service. We use the ERA 5 reanalysis data to validate the wind stress. But today we are going to focus just on the geostrophic term, because it's where we use the Copernicus Marine Service data, and also because the surface circulation is mostly driven by this geostrophic term. Okay, starting with the model evaluation. Here I show you the observations, the satellite observation, and here is the reanalysis. And as you can see, we found a meridional gradient with negative values in the northern coast, with switching to positive through the southern coast. And as you can see, we observe the pattern that I explained at the beginning, with this entry of Atlantic water through the Strait of Gibraltar flowing eastward. And also it's important to note that the dynamic sea level gradients corresponds to these surface streamlines of the circulations. Well, when we add all the models, we found like a highly variability response of all the models, but most of them generally represent qualitatively well the spatial patterns with the lower values at the northern coast, with the minimum located here in the cyclonic gyre in the Gulf of Lion, and the maximum related to those anticyclonic gyres, like here in the Alboran Sea. And the models who present the higher resolution are able to better reproduce this pattern, the observed pattern, while the model with lower resolutions, like UVL, it's present like more deficiencies to simulate the current surface circulation. Then, to summarize information, we also use those plots, the Taylor diagram and the Taylor skill score. In the upper one, the Taylor diagram, we take into account in the X and Y axis the standard deviation, here with the curve with the correlation, and the semicircles corresponds to the root mean square error. Here we put with the start our reference data set, which is the satellite observation, and the gray dot corresponds to the Siemens reanalysis. As you can see, the values, the models who present the higher correlation and the lower root mean square error fall in the uncertainty of this behavior of the reanalysis. And here is summarized, here just the value of the Taylor skill score represent that one is a perfect reproduction. So models with higher resolutions are those which fall in this uncertainty of the reanalysis. Well, then we also analyze the variability associated to this geostrophic circulation. And here from our reference data set, we observe that the highest values are located in areas where we find this mesoscale activity, like here in the Alboran Gyre, the Algerian current, and most of the models are able to reproduce those high values in the northern Alboran Sea. But contrary to the observations, it's a struggle to reproduce this variability localized in the Yera Petra gyre. And then we put we plot the basin average value in dashed black line. I present the value for the observation, and in gray for the cements. Each color represents a model, and we found that around 11 kilometers of horizontal resolution is required to successfully reproduce the observed average variability in the Mediterranean basin. Then we try to identify the main source of variability in the Mediterranean Sea. So we decompose the signal in 3 different frequencies. We decompose in interannual variability, seasonal, and intraseasonal. And from observations, we learned that the main source of variability is localized in the intraseasonal frequency, and most of the model also successfully reproduce this main source of variability. Well, now if we move to the future climate, here I show you the multi-model ensemble mean at global warming level 2 and 4. And to really identify really robust signals where we find the robust changes, firstly, we add the hatchet areas to reproduce areas where changes are not statistically significant. And also we add a multi-model agreement criterion. This consists in selecting only those grid points where at least 8 out of 11 models agree in the signs in the sign of the change. Okay, otherwise we mask in white. So as you can see, at basin average we cannot find strong modifications of surface circulation, but locally we identify two main regions here in the Northern Balearic Sea with a cyclonic, anticyclonic trend, and also here in the Southern Adriatic. As you can see from global warming level 2 to 4, the spatial pattern don't change too much, but the intensity almost doubled. This suggests a linear response with increasing global warming levels, and this is why we find here. Here I show you the percentage of occurrence of different circulation modes. To compute those circulation modes, we firstly calculate the vorticity, and then we define different modes subjectively, but based on the physics of each area. And this allows us to analyze those different circulation modes. So in the northern Balearic, we found this change from cyclonic to anticyclonic, while in the Southern Adriatic, we found an enhanced circulation, a cyclonic circulation at high global warming levels. Well, but now if we focus a bit more in detail for this Northern Balearic Sea, okay, we found this linear response. We found an increase of the anticyclonic frequency at high levels of global warming. But here, the models are not really good reproducing the values, the percentage observed and reported by the reanalysis. So this suggests that we need to apply an observational constraint to fix it. Well, so that's exactly what we did. And here we have, I show you the observational constraint. In the x-axis, I plot the percentage of cyclonic circulation during our assessment period, and in the y-axis I plot the percentage of the change of this cyclonic circulation at global warming level 2. In the middle is for all the global warming levels, and the last panel is for averaging all the global warming levels. And here the black line with the shadow area represents the observations and the error. So if we just keep the models that fulfill the observations constraint, which in this case are ENEA and CNRN RCSM6 model, we can see that using just those models, we now are able to reproduce the circulation pattern during the baseline periods, and without changing our conclusions, but because we are still finding this change from cyclonic circulation to anticyclonic circulation. From this analysis, we also find an emergent constraint, which is I mean, from the yellow line, we have a strong correlation, and we found this emergent constraint when the orange area cross the gray area. So, for example, here, averaging all the global warming levels, we can say that per global warming level, we have an emergent constraint of which results in a reduction of between 10 and 20% of this cyclonic circulation per global warming level. And from this analysis, we learned that semin products provide a key reference for evaluating the ability of regional climate ensemble to simulate present-day Mediterranean surface circulation. And you can find more results and conclusions in the paper. Thank you very much. And if you have any question, I would be happy to answer them.
Thanks a lot for the presentation, Ivàn. Right on time also for the timing, so well done. So yeah, we have a few questions for you, so we will go to that part. So the first one being, how can we explain the differences, sometimes big, between the different models? Is it just about resolution?
Yeah, it depends not only about resolution, it also depends on the driving GCMs, the boundary conditions. Many things can play a role on those differences. And we also have to know that these runs that I'm using are historical runs, are not evaluation runs. So there are not following like real chronologies and are not the best to assess the present climate. But in this case, we just wanted to see how the historical runs performs reproducing the present climate, and then move to the future analysis, considering all the models as possible future response.
Okay, thanks a lot for the detail. Okay, so this one is cool. Do the 11 kilometers you've mentioned correspond to specific phenomenon in the Mediterranean, or would it be the same scale in other areas?
Not really. I would say that here, well, mesoscale structures in the Mediterranean Sea can have a Rossby radius around 15 kilometers and can be related with this, but not sure.
Okay, thanks. An extra homework to do, extra research. Great presentation. So what would be the consequences of the shift from cyclonic to anticyclonic?
Yeah, this is a really good question. In the original aim of our work, it was to study how global warming can impact to those changes in surface circulation, mostly related to connectivity between species, with an special focus on the northwestern Mediterranean. So it means that, for example, species like larvae from gorgonias, let's say, can be isolated in this jar due to this reversal of the jar. So, for example, this is one of the main consequences, and also we can have a local warming. If we see other analysis, other studies, like the ones carried out by Soto Navarro in 2020, I think, we can find like a local warming in this northern Balearic Sea, which fits with the place where we find the reversal of the jar. So it can also lead to this enhanced local warming.
Okay, thanks a lot. And do you know if some extra studies have been done to study these consequences, or is it just...
No.
Okay.
I think no.
Okay. Another question. Thank you for your presentation. It was a very interesting work. I was wondering if you saw any particular trend regarding the future circulation of the cyclonic Rhodos
jar. No,
yeah.
in our study, we didn't consider this jar because we mainly focus on those areas where we found a robust signal, or also we also include some of them which are relevant for Mediterranean circulation, like for example the Northern Ionian gyre reversal, but we didn't focus on Rhodos gyre at this time.
Okay, maybe another time.
Yeah.
Next question. Good presentation. Why don't you use salinity data to validate the model and evaluate vorticity?
Okay, so in this case, we just focus on surface circulation. So from model data, we just collect the dynamic sea level and wind stress. And from this model outputs, we retrieve the surface circulation. But we didn't have access at this point to salinity data. So we use the data that we succeed to collect, and that's the main reason.
Okay, thanks a lot. So for now, this is the last question. What is the lifespan of these cyclones and anticyclones?
What do you mean? What lifespan? I don't really...
Yeah, I guess How long would
the duration of each year, I don't know. I think that I cannot answer this question because in our data, we are using monthly values. So we are filtering out a lot of the signal that, for example, it can change with the winds or with a daily scale, let's say. But I cannot give you an answer using those monthly data.
Yeah, I guess it also depends on like the season and everything.
Yeah, and also we just pull all the models outputs and we compute the percentage of each cyclonic or our anticyclonic mode, but we didn't really analyze the time variability of these jets. But it will be super interesting for future.
Okay, thanks a lot.
Thank you.
I guess that's the last question for your presentation. So thanks again. It was really interesting. And yeah, also there's some kudos in the chat.
Thank you.
So now we will just do a small break for the participants. So a 10-minute break. And so yeah, feel free to look at the polls, and we've prepared a fun work cloud to get to know you better, so you can enter what the subject of your work is, and it will appear on the screen. And if you don't want to do that and go grab a coffee or something, feel free to do so. And we will see you in 10 minutes for the last 2 use cases of today. Bye. Welcome back, everyone. We will now go to the two other use cases of today, and we will start with John's presentation about the plastic drift in the Greek seas. Welcome, John.
Good morning. Hello, everyone. As mentioned, my name is John Karagiorgos, and I'm a PhD candidate in physical oceanography at the University of Athens. In this presentation, I would like to show a use case of Copernicus marine data within a project focusing on the backtracking of plastic drift in the region of Greek seas. The area of Greek seas is a very sensitive region to plastic pollution, as it has the longest coastline in the Mediterranean and a dense network of islands that create a very complex ocean circulation and many routes for plastics to move and accumulate. So plastics enter the sea from many sources. Some are land-based, including urban and tourist activities, rivers, and even illegal landfills. And some others are sea-based sources, mainly related with the fishing activities and the intense maritime transport. As an example, you can see the map at right shows the ship traffic density across the eastern Mediterranean. So, as you can see, there is a strong pressure from maritime activities in the Aegean and their potential contribution to marine debris. So along the coast, many volunteer projects and local communities often report seasonal peaks in plastic accumulation. And many of these items clearly originating from distant islands and offshore areas. So the monitoring of such an accumulation is very important, not only for the marine ecosystems, but also for the environmental quality of popular beach locations, and particularly their blue flag status, which has a direct impact on the tourism and the local economies. So, in our use case, a collaborative work between the University of Athens and the Fourth Research Institute in Crete, we aim to map sources of plastic that arrive on a given beach location, and to identify seasonal transport pathways with an ultimate goal to inform target mitigation planning and cleanup efforts. So, for this use case, our simulations based on the Ocean Parcels model. It is an open source Lagrangian modeling framework that can simulate the movement of passive or active particles in the ocean, either forward in time to identify where the particles will move, or as in our case, to identify the likely sources of origin. The Ocean Parcels is an efficient framework written in Python and C programming languages. The outputs can be in efficient formats like jar, while it supports the MPI parallelization for large-scale experiments. It has fast prototyping and extensibility features for the end user, so someone can create very quickly different numerical experiments and scenarios, and also to adapt forcing fields from various sources of ocean data, and also can create custom kernels for specific particle operations like sinking, swimming, biofueling, or interactions between particles. Importantly, the Ocean Parcel has a fast-growing user community. Since its first release, more than 250 works citing parcels, so it provides a solid foundation for our simulations. Next, regarding our experimental protocol, we produce an ensemble of back trajectories for a previous 10-year period where we released the passive virtual particles from known locations and at a daily frequency. In this presentation, I will present results for a popular coastal location in Crete Island called Pachiamos as a demonstration case within the Aegean Sea. Here it's important to note that the plastics were constrained only to the surface, and we track them back in time for 60 days after the first release. These particles used here as a generic proxies for floating particles, as we don't simulate here varying sizes or densities, but they capture the first order transport pathways. So for the forcing of the ocean parcels model based on Mediterranean Copernicus reanalysis products for the Mediterranean at a high spatial resolution, about 4.5 kilometers, and specifically for we use the physics reanalysis, the surface currents from the physics reanalysis, both at daily and hourly frequency. And from the wave reanalysis, we use the Stokes drift velocities at hourly frequency. For this presentation, we performed two sensitivity tests closely related with the availability of Copernicus data. The first one related with the temporal resolution of ocean data forcing, and the second one related with the influence of Stokes drift in the simulated trajectories and particle dispersion. So in the results, our ensemble of back trajectories shows a clear seasonal cycle, shows seasonal patterns. Here you can see the aggregated tracks over the whole 10-year period and for a representative month per season. So here, moving from spring, from April and spring to winter, the trajectories shift in an anti-clockwise sense around the release region, reflecting the seasonal circulation in the Aegean. As a consequence, the sources for plastics move progressively from the southeastern Aegean and the Rhode Island to the Dodecanese Islands and the west coasts of Turkey. Next through the Cyclades, and some of the particles seems to arrive at the beach location from the eastern mainland of Greece. Next, looking at the bottom panel, we found that the strongest connectivity linked to the remote sources occurred in summer months, where the average travel distance for our particles can reach up to 200 kilometers. While in contrast, during winter, the travel distances are much shorter on average, below the 50 kilometers, which suggests that the particles are circulating around the release location, and it is an indicative result for a more localized sources of plastic inputs. Here we present the results regarding the temporal evolution of current fields. So for a representative month of July and the whole 10-year period, we compare the trajectories between the simulations with hourly surface currents and daily surface currents. So, as you can see in the left panel, the main pathways are largely unaffected, despite the frequency of the resolution. But when we look closer, hourly currents increase the final position spread of the simulated particles, and also increase the total accumulated distance, with differences up to 100 kilometers in some years. More importantly, the hourly forcing reduces the mean residence time in the wide area of the release location by up to 1 day compared to the daily forcing, which is a particularly important result for especially for short-term predictions. In the next slide, we explored the influence of wave-related processes and the Stokes drift. Again, during a representative month of July. Here in the left panels, you can see the mean surface currents during July and the Stokes drift velocities. As you can see, the Stokes drift patterns have a southward direction that are closely related with the Tisian winds, which persistently blowing from the north during summer in the Aegean, and creates strong surface waves and the associated Stokes drift. So, adding the Stokes drift velocities in our forcing, as you can see in the middle panel in the green lines, the Stokes drift induces a westward shift of trajectories by half of a degree, or around 50 kilometers, along the wave direction, and also increases the dispersion in the final positions. So the results highlight that the wave processes can be particularly important during summer months in such locations. So to summarize, our results reveal that the high resolution Copernicus data are vital for addressing the growing challenge of plastic pollution in the region. Multi-year simulations reveal seasonal and interannual transport patterns, while we find that high-frequency currents reveal faster near-shore flashing and more complex trajectories. And finally, we saw that the Stokes drift can significantly shape the particle pathways and its dispersion along the wave direction. So we are extending this work in three main directions. Firstly, we are combining both backward and forward tracking simulations to better understand the dispersion patterns. We are exploring other physical processes, especially related with the varying particle sizes and densities, vertical mixing, wind-induced drift, and biofouling, while we try to develop a web-based interactive platform for visualizing likely path and destination of plastics in real time for the end user. So to conclude, our methodology is scalable for other coastal areas instead of the Pachamos presented here. And some scripts to run parcels and visualize its results can be found in this link at GitHub. So if you have any questions, you can contact me and send me an email to this address. So thank you for your attention, and I would be happy to answer any question. Thank you.
Thanks a lot, John, for your presentation. It was really interesting. And yeah, we have a few questions for you, obviously. The first one being, why the limit of 60 days of travel time?
Yes, this is an ad hoc decision because we want to travel to track just to cover the longest pathways. It's an ad hoc decision.
Okay, thanks. So the next question, so if higher temporal resolution has minor impact on the pathways, will you keep using it or will you use daily data?
Yes, our results show that with the daily data you can capture the main pathways. But when if you for example want to perform short-term prediction experiments for beaching for particle beaching, etc., the higher frequency currents may be more important, especially for an operational projects. But for a general picture, the daily data captures well the main pathways.
Okay, thanks. Yeah, okay. Oh, okay. Very interesting. When are you planning to publish the paper of this research?
Yes, this is a work on progress. We hope in the next year with our colleagues from the Fourth Institute in Crete to publish some of these results. Thank you for your interest.
Thanks for the... Okay, so this question, so from a Greek person, I guess, Kalimera John from the University of the Aegon. Great presentation. What do you consider the biggest challenge when using Copernicus data for tracking plastic pollution? Also, is there any point in future studies to use bathymetry data?
Yes, I started for the latter question. In our future studies, we want to perform simulations with a 3D movement of the particle because here we have only surface only advection. So there the bathymetry data will be significant. But for the first question, the biggest challenge was that the mask of Copernicus product for some of small islands introduces some discrepancies in our field. So we masked, in some cases we masked them, or in some other cases we performed a small interpolation to better capture the beaching effects and with real islands and all of this. But the high resolution are quite useful for such a study.
Okay. Thanks a lot for the explanation. The next question, what was the release frequency of the particles and how many particles were released per release event?
Yes, we released the particles for a specific beach location here, the Bahiamos, at a daily frequency and for the whole 10-year period. So we have 360 particles per year. In our future plans also is to release particles in a wide area of instead of a point, the closest point in the beach. So to have to see if we have a different response. But yes.
Okay, good to know. Thanks. Next question. Thanks for the talk. Did you use a diffusivity kernel?
No, here we don't use a diffusivity kernel, but I have performed some tests with a constant diffusivity, but without any significant, very significant difference in the main pathways and the seasonal patterns.
Okay, thanks. Yay. Okay, yeah. Next question. So I would like to ask whether the Copernicus data you used is capable of detecting all types of plastic, regardless of their size, whether microplastics or macroplastics.
Yes, the Copernicus data only used here as a forcing to advect the passive particles, but it is not dependent. It is not related with the size or the type of plastic. This process is related only within the ocean parcels model. How to simulate processes of sinking and upwelling and biofouling, for example, but it is independent from the use of currents.
Thanks. I think so. The next question is for now the last that we have, more general question. Thank you so much for your presentation. My question is there any data that can provide us about effect of plastics in marine environment?
I don't know any specific source, but it's widely accepted that plastics can affect the marine life and the health of marine ecosystems. It's a fast-growing pollution source of pollution, but I don't know specific data about this effect.
Yeah.
This effect.
Yeah, I guess you would have to download several type of data sets and make a cause to effect study on plastic on marine life.
No, especially for the marine ecosystem, because it is closely related, especially the microplastics related to the have a significant effect on the marine life.
Yeah. Thanks. Okay, another question. Thanks for the presentation. What mathematical model did you use to simulate the trajectories?
We used the ocean parcels model is a Lagrangian modeling framework. So the particles advected only by the current velocities as a passive tracer.
Yeah, we will put the link.
You can visit the full documentation of the ocean parcel model to find exactly the equations that it solves and how it works in the grid.
Yeah, we will put the link.
Yes, I have the link
on the chat for the participants. Yeah.
Okay.
So yeah, that was the last question for you, John. Thanks a lot for your presentation.
Thank you very much.
See you. And yeah, so now we will go to the last use case of today with Paola Tepsich. Welcome, Paola.
Hi, good morning to everyone. Thank you for introducing me. Today, I will present our research. I say our because basically this research has been done by my colleagues also, Francesca Grossi, who cannot attend today because she's out at sea, basically doing what you see in the picture, so monitoring the cetacean presence. And today we will show you how we use Copernicus Marine data products to study the ecosystem of the Northern Ligurian Sea, from the tiniest to the biggest living organisms that we can find there, so from plankton to whales. First, I would like to introduce you CIMA Research Foundation, which is a research institute based in northern Italy, in Savona, which deals with the study and prediction of effects of climate change on different parts of the ecosystems. Specifically, me and Francesca, we are part of the Marine Ecosystem Department, and we deal with the analysis and understanding of the effect of climate change, especially in the marine realm, with the focus on the high seas, so the pelagic areas. Being based in Savona, which is the blue dot that you see along the coast of the Liguria region, we are ideally in the center of one of the biggest marine protected areas of the Mediterranean Sea. born from an agreement between Italy, France, and the Principality of Monaco. The Pelagos Sanctuary is a protected area dedicated to the conservation of marine mammals, and specifically cetaceans. This area is known to host one of the main productive events, so a spring phytoplankton bloom that is shown in the map where the green region are shown, which basically triggers a very strong food web, which is able to sustain and host even the largest animal in the world. What you see in the video, I'm sorry, it's a bit scattering, is basically a fin whale. So it's the second largest animal living on our planet, second only to its cousin, the blue whale. And it's a resident mysticid species in the area. So, as just said, we all know that the phytoplankton communities are essential for healthy and productive ecosystem, as well as we just did, chlorophyll A concentration is the main indicator used to analyze the biomass of phytoplankton. And while the Mediterranean Sea is usually known as a low productive area compared especially to the oceanic basins, we also know that the Ligurian Basin in the Northwest Mediterranean Sea usually hosts higher chlorophyll concentration value within the basin, basically as it hosts one of the largest bloom during the spring period. This is also known as one of the only consistent blooming and recurrent blooming areas of the entire Mediterranean basin. Our analysis was part of Francesca Grossi's PhD, and the first one of the chapter of her thesis deals with the analysis of the spring phytoplankton bloom in the northwestern Ligurian Sea. The aim has been to analyze the bloom using specific phenological indexes from 2008 to 2022, so in the last, let's say, year, especially to understand the trends and anomalies under current climate change situations. And to do so, we coupled the analysis also with oceanographic as well as other meteorological variables. You can find more information about the research in the paper that is shown, which was published last year. Basically, considering our study area, you can see still the Pelagos Sanctuary in the blue area. We identified 5 different sites, which we know are important from a biodiversity and habitat point of view. And we took these 5 sites in order to analyze the bloom trend and anomalies inside of each area. And our interest will go specifically in the seamount and pelagic area, and I will explain later why. So basically, we use the daily maps of sea surface chlorophyll concentration downloaded from the Copernicus Marine Services to identify and map the blooming period, and it's already very visible how a strong interannual variability in the strength and displacement of the bloom is occurring in the region. And we use the daily data also to characterize specific phenological indexes, such as indexes based on the intensity of the bloom, so the minimum, the maximum, and the mean chlorophyll concentration, the amplitude and duration of the bloom and also the peaks. All these indexes have been analyzed in order to identify trends and eventual anomalies. To understand the effect of current climate change condition, the analysis also regarding some meteorological variables such as rainfall, land temperature, and consecutive number of dry days, as well as some oceanographic variables also downloaded from data available on the Copernicus Marine Services dataset, such as sea surface temperature, temperature at 400 meters depth, and the thickness of the mixed layer depth. And these data have been analyzed in the winter period, as we know that the winter conditions are the one triggering then the spring bloom in the following months. For brevity, again, we will show the results regarding the seamount and the pelagic area, because are the area where we know that the final species of our interest, so the fin whale, is mainly distributed. We can see from these graphs in the shaded area, in the green or blue for the two considered area, how the intensity of the bloom is basically decreasing in both areas, especially in the last 5 years. As also we can see in the box plot, a variability in the duration and in the peak of the blooming season. Also, a decrease in the blooming area is present in both considered sites. Then we also analyzed anomalies. These graphs are showing the standardized anomalies. So the red explain a positive anomaly and the blue a negative anomaly. And we can see that for all the metrics dedicated to the analysis of the strength of the bloom, we have negative anomalies almost constantly, especially in the last years. Basically, in almost all areas, also the oceanographic variables showed strong trends for both the decrease of the thickness of the deep mixed layer, as well as an increase in the sea surface temperature, and also an increase in the temperature at 400-meter depth. The variable most correlated with the bloom in our region were, again, the sea surface temperature with a negative correlation. So an increase in sea surface temperature is correlated a negative trend for the blooming area, as well as for the mean and duration, where land temperature, and consecutive number of dry days are having a negative effect on the mean and the duration of the blooming period. These all basically gives us information on how the current climate change condition on both land and oceanographic variables are having a strong negative effect on the blooming period in the richest area of the Mediterranean basin. Our results also shows that the area, the minimum and the max of the blooming are actually the most appropriate indexes that we should be using for analyzing possible shifts. And in order to this analysis to be useful also from policy and conservation point of view, we also try to do the analysis regarding the different reporting period of the marine strategy. So the first period from 2008 to 2014, and the second period from 2015 and 22, respectively in red and in blue. And we can see from the box plot that an evident negative shift is present from the first to the second period. We also know that both sea surface temperature and temperature at 400 meters depth has increased significantly in the last years. And what was also interesting to notice was how the meteorological variables regarding the land temperature and especially the number of dry days show a strong correlation closer to the coast, but also in the very pelagic area, which are the one of our interest. Then, once having almost understood and described the effect on the phytoplankton, we try to use the same data set also to understand and map the distribution of the fin whale. This is another chapter of Francesca's thesis, and you can see the paper where you can find more information. And this analysis starts from data collected on board of ferries, which have been used as platform to collect data on the presence of the fin whale in the northwestern Mediterranean Sea. And in yellow, you can see all the routes along which observers have monitored and collected the data on the presence of the species. As we can see from the red dots, which are our sightings collecting from 2008 to 2022, the species is constantly present and very diffuse in the area. In order to build habitat model, the aim is to correlate the species presence and especially the species absence to different environmental variables. The ones that we have used are both topographic, so fixed variables such as bathymetry and slope, as well as oceanographic dynamic variables, so chlorophyll concentration, sea surface temperature, the mixed layer depth, and the eddy kinetic energy and the finite size low pilot exponents, which are both variables connected to the dynamicity of the mixing of the waters at different depths. And all these variables, again, are directly downloaded or derived from dataset presence on the Copernicus Marine Services. For brevity, I will show only the results gained by the use of generalized additive models, but the paper also explores other modeling frameworks. But GAMS in particular have been applied to understand the habitat suitability, so to understand the areas where the species is more likely to be present. And again, we can see a strong interannual variability, both in the amplitude of the area where the species could be present, and especially on the intensity of the presence of the whales. Concerning the different variables, while bathymetry is known to play a crucial role in distribution of the species, we also found out that especially chlorophyll has a strong importance in describing the habitat and as a consequence the density of this species. This is not surprising because being a filter feeding organism on zooplankton, its presence is almost directly correlated with the spring phytoplankton bloom. And this has been further demonstrated by the fact that the variables for which we find the stronger effect on the fin whale density and distribution is the chlorophyll with a lag of 2 months. Knowing that this species is present specifically and especially during the summer season, so from May on, the chlorophyll concentration with a lag of 2 months directly reflects to the chlorophyll concentration during the spring blooming period that we have analyzed and explained before. And also for these models, we have evidenced a very high interannual variability for every prediction for GAMS and also for the other habitat models. These making very difficult to predict correctly on a yearly basis the species presence and distribution. But indeed, this analysis has given us more information on the possible functioning of this very important area from an ecosystem point of view. And so I thank you for your attention, and I'm at disposal for your questions. Do not hesitate to also write me and Francesca for any further discussion on the topic.
Thanks a lot, Paola, for your presentation. It was really interesting. And yeah, we have a few questions for you. The first one being, what is the starting temperature that causes less bloom?
Thank you for your question. Indeed, we didn't find the specific variables or ranges. It's more a mixture of different variables. More than temperature, actually. We found that it's a combination of warming winter periods, so prolonged warming periods during the winter time, and especially actually the lack of rainy periods, so the increased number of consecutive days of dryness in the period.
Okay, thanks for the details. We'll go to the next question. Yeah, it's okay. Until what distance to the coast do the meteorological variables have consequences?
Well, we do have some, if you remember the map with the 5 different sites, basically already the seamount and the pelagic area are quite far from the coast. And so basically what was interesting is that also areas that have been chosen because being very pelagic, we know that meteorological variables do have an effect. Maybe not directly, but the indirect effect, considering the functioning of the atmospheric and oceanographic condition, basically have effects everywhere in the basin.
Okay, thanks for the explanation. So the next question, okay. Concerning the whales you've tracked, did you notice less of them along the tracks between 2008 and 2022?
We did not find any specific trend, so we don't see a diminishing, rather an increasing trend, but we have a strong internal variability. So we have had a very positive year, especially like 2022, for example, as well as very negative one, like if I remember well, 2014 was a very bad year, let's say, for whales. It is true that what you see out at sea, more than abundance, let's say, is a higher concentration, so a higher frequency of encounter, which does not really directly reflects an increase in abundance, as we basically monitor only what we see along our tracks. So it's a very restricted view compared to the possible distribution of these species.
Okay, yeah, we can still say it's good news at least, but
yeah.
So this one, I think it was about the end of the presentation. Habitat sustainability is best if high or low on the last figure.
Yeah, it's habitat suitability. So indeed, higher values, so the red, indicate a higher probability for the species to be there. Let's say a higher probability of the variables influencing the presence of the species to be positive for the species.
Okay, thanks. The next question, it's a bit slow to highlight. Okay. Was there an extraordinary bloom event the years the whales were more present?
Yes, even though we have found for the richest year for fin whales that sometimes was the higher intensity of the bloom and sometimes was the higher duration of the bloom. So we are still trying to understand the best combination of duration and amplitude to understand this. Indeed, we have more information on the negative years. So basically, when the whales are less dense, let's say less present, is those years where the bloom was very restricted in time and never really fully developed in the usual areas, because we also need to remember that these are mammals. So these animals basically do also have a kind of memory of the richest area. So whenever coming back in the region, they usually come back where the year before they found food. And then if they don't find it there, they start wandering around looking for other possible feeding grounds. So basically the years when they disperse more is those years when they need to start wandering around because they don't found their usual feeding ground where it was supposed to be.
Okay, thanks a lot. Yeah, I guess it kind of answered the next question. I will still read it. So thank you for your presentation. I'm not sure I got it properly. Is there a match in the timing of bloom with the peak presence of whales? Does the 2 months lag in chlorophyll mean the whales are expected to peak in presence 2 months later?
Well, yes and no. First of all, we have one limitation, meaning that what happens during winter and spring can be monitored by satellite, but it's very difficult to monitor the presence of animal out at sea because of the not ideal sea state condition, while we have plenty of data on the whales during the summer season. So we need to basically try to understand what we see during summer to what happened during spring and winter. But it was interesting to understand that basically we do have a correlation between the high areas in spring in chlorophyll concentration and the higher areas of density of whales during summer. And the lag is also easily explainable considering the food chain steps needed to go from the chlorophyll to the zooplankton krill. That basically is the real food of the fin whales.
Okay, thanks for the explanation. So the next question, do you have any information about the species in the bloom of the phytoplankton in this region? And if it's changed the species or it's the same? Thank you in advance.
Thank you for this very interesting question. It's exactly the question we have in our mind, basically, because using chlorophyll concentration as an index to understand the phytoplankton biomass, we don't really go into the species-specific understanding of the phytoplankton bloom. I can say that by discussing this with some phytoplankton researchers, they basically are starting having in situ data in some areas of the Mediterranean Sea, where basically they state that the main change, again, is exactly in the species. So the change we see from satellite data in chlorophyll concentration, to them is more a change in the type of and species of phytoplankton rather than the quantity, let's say, of phytoplankton itself. So indeed, this should be investigated further.
Okay, thanks for the details. So this one, how did you obtain sea surface temperature and temperature at 400 meters with a resolution of 1 kilometer?
It's one of the data sets that is present in the Marine Copernicus services from the reanalysis oceanography physics. I think it's 1.4 kilometers, the final resolution. So I must say it's not observed, it's modeled.
Yeah.
So.
So the next question, we still have plenty of questions coming in. So thank you for the nice presentation. Do you plan to include causality analysis, not only correlation, to study cause and effect links between the variables?
We did think about this. What we are missing are some intermediate steps, because we are looking at variables which do have a lag in the timing and space of the cause and effect. So we feel the causality, before going to causality, we need to feel more in between steps inside the variables.
Okay, up next, so to be continued. Okay, it's still a bit slow to highlight. Okay. Thank you for your presentation. I wanted to ask whether salinity was included in the model, as it's an important factor in this topic. I'm asking to verify because my internet connection was unstable.
No, we did not include salinity, and the reason is that especially for salinity, we feel that the data are mainly modeled with few in situ data to actually understand the real variability that it's going on in that variable for now. And also, given our interest in the end on the fin whale, for now, salinity was not explored. But there are analyses going on that, because we totally agree that salinity plays a crucial role in that.
Okay, thanks. So a more general question about the data. So I have one question. Is this data available for MEA region? I think it's Middle East. I asked the
is it the data? I mean, if it's the oceanographic and data, I think the global data sets are present on the Marine Copernicus Service.
Yeah.
If it's the species data, not in my knowledge, but I think you can look. There are some portal like the OBIS CMAP and the GBIF, where marine species distributions data are present.
Okay, thanks. So still another question about external data. Is there a database for presence of big marine species in the Mediterranean that we can access? So I guess you should know, yeah.
Yeah, once again, indeed, there are some data sets present on both the IMODNet portal as well as the OBIS CMAP, but also the data set we have used, since it's the product of several European funded projects, it's usually available for sharing. So if you want just to contact me, I can share more information on that.
Yeah. Yeah, we will put the slides available for everyone. So if you want to contact Paola, you will be able to find her email address on the slide.
Yeah.
Yeah. So we'll do just one last question, which is not really about the presentation, but more about where you work. So thank you for your presentation, amazing work. I'm so Yeah, I was wondering if you accept possible PhD application or if the institute you work at accepts internships. I guess you do like every lab you publish on the website.
Yeah, exactly. There are all the information to apply for internship as well as a PhD possibilities on our website, or contact me. I will share all the information.
Okay, yeah. So same answer, you can check the email or the website for more info.
Yeah.
So yeah, that was the last question for you, Paola. Thanks for the presentation and the Q&A.
Thank you.
So yeah, we are reaching the end of today's session. So thanks again to all of the speakers for their presentation and for your questions for the participants. So before you leave, I just want to remind you that there is a section on the website next to the Q&A, which is dedicated to the polls. So we would really appreciate to have your feedback on today. And also, I'm just seeing that I'm not on the right slide, but for the second day of this webinar, we will have the tutorials practical session. So you will be able to find the tutorials on the website. You will have the full codes, documentations, and the full video demonstration available. So don't hesitate to have a look before our second day on Thursday. And then you will find the Q&A section, the poll section on the website. So if you could answer the polls, it would be really helpful. And just so you know, the replay of today and the PDF presentation will be available during the day. You will receive an email once it's uploaded on the website. And yeah, we will see you in 2 days for the practical session, and have a nice day.